present our research paper titled Application of Game Engine-Based Safety Training Tool in a Middle Eastern Country. The paper is authored by myself and Professor Hiam Khoury from the American University of Beirut. So in this presentation, I will start with a brief introduction, and to set the tone of this presentation, I will briefly go over some previous work related to the application of game engines in construction safety. I'll then go over the research objective, tool development, results, and finally, I will conclude this presentation. So unfortunately, the construction industry is one of the most dangerous industries when it comes to workplace safety. In 2017, and according to OSHA in the United States, 20.7% of fatalities among all working industries was from the construction industry alone, which accounted for 971 fatalities. In the UK, 28.9% of fatalities were from the construction industry, and in Saudi Arabia, 48% of the fatalities were from construction. Now, although construction safety is a global problem facing the industry, the numbers show that the problem is more serious in the Middle East region. And one way to mitigate safety hazards is through the proper implementation of training programs. Thus, more research in the past years has focused on enhancing safety training in construction. And one way researchers are enhancing safety training is through the use of game engine technology. So game engine technology started to gain popularity in construction in the year around 2009, where Zhao et al. Developed a training simulation to train excavator operators on how to safely maneuver in close proximity to dangerous electric hazards. Then researchers started integrating 4D with safety training in order to create a more realistic training environment for the workers and based on the current construction phase of the project. And more recently, researchers are investigating the use of augmented and virtual reality to create a more immersive training environment. So all in all, research has showed that using game engines or serious games increased the motivation for training among workers. It facilitated the learning experience and had a more effective transfer of knowledge in comparison to the traditional training methods. So diving into our research, the overarching objective is to mitigate safety hazards through the development of a digital and integrated safety management system. The system is made up of 3 components. The first component is related to safety training and assessment, while we relate to safety, the first component is related to the integration of safety and construction activity planning. The second component is related to safety training and assessment, while the third component is related to resource allocation. So the system is used to connect the data from all 3 components in an integrated digital platform. Planning-related data such as execution dates and risk scores of activities are sent to the second component, where the safety training and assessment scenarios are developed in a virtual environment based on the inputted data. And after training and assessing all workers, the data collected, such as their safety performance and the risk scores and resource requirements of activities from the first component, are sent to the resource allocation component. However, believing that the need for technology should come from the people, this research focuses and presents our work on the second component related to digital safety training to test if workers in the Middle East are ready to accept and use this technology. So in this context, the objective of this study was to develop a location-based safety training and assessment tool, which trains workers based on their specific activity in its upcoming execution location and assesses their performance and gives each worker a safety score. And the second objective was to test the tool on workers from the Middle East and to obtain feedback about the tool and its potential adoption in the Middle East. So we used the game engine Unity to develop a safety training and assessment tool for construction workers. And the first step was to build the project's virtual environment. So we had a 4-story residential building, and we used the HDRP pipeline to create high definition and high fidelity graphics to create this realistic feeling for the workers. And this is how the UI was built. So the user first must choose whether they want to enter the assessment or the training program. If they choose the assessment, then they will choose the activity they want to be assessed in. If they choose the training program, they will then have to choose the activity, and they will have to choose the location in which they want to be trained in. As for game controls, they were developed in a way to be user-friendly so that we take into consideration that some workers might not have any gaming or computer experience. So the first controller is the keyboard, where the workers will use the arrow or the WASD keys to navigate through the site, and they will also use the mouse to point at and click certain objects in the game. So here I'll show you a small demo of the training tool. So the user goes to the assessment program and to the concrete activity. And here we can notice that each worker has a unique ID, and the score increases each time he identifies a safety hazard or a safety violation. And the score is between 0 and 70, 70 being the highest score. So here, for example, we have missing rebar caps, which can danger a worker if he falls onto the rebars. Here, some objects are thrown next to an opening, and even if we have a barrier, it's a dangerous thing to put objects near an opening. And for the sake of time, I will not go through the whole demo. So after developing the tool, we tested it on 25 construction workers. We had 3 age groups between 20 and 30, 30 and 40, and greater than 40, and 3 experience groups between 0 and 5, 5 and 15, and greater than 15 years of experience. We noticed that the majority of workers obtained acceptable safety scores, where 10 obtained a safety score in the medium range. And as a reminder, the safety score is between 0 and 70. So 10 had obtained a medium safety score between 21 and 45, and the remaining 15 obtained a safety score in the high range between 47 and 70. High safety scores reflected the following results, where most participants acknowledged that the game increased their motivation for training. So they wanted to obtain, and they were intrigued to obtain higher scores. And they thought that the game helped them increase their risk perception skills. And finally, the workers validated the scores by acknowledging that their safety score truly reflected their safety knowledge. And workers were also asked whether they prefer this method or the traditional passive methods, such as toolbox meetings, PowerPoint presentations, or videos. So 23 workers preferred serious games. And also the 23 workers suggested that workers in the Middle East are ready to accept the implementation of this technology. Now, due to COVID restrictions, we were only limited to 25 construction workers, so the results are not used to generalize over the whole population, but are used to assess the developed tool and to give an indication about the perception of workers regarding this training method in the Middle East region. So to conclude, this research proposed and developed a game engine safety training and assessment tool and tested it on workers in the Middle East region. Feedback showed that the tool effectively trains workers on safety measures and accurately assesses their safety performance. The results of this study indicate that the other objectives of this research can move forward, as this technology will be accepted by the end users in this region. And so work will focus on integrating this tool into a unified safety management system. Thank you, and if you have any questions.